this question here that says prove by induction that 1 cubed plus 2 cubed plus 3 cubed plus 2n cubed is equal to n squared plus n squared open brackets n plus 1 squared divided by 4 here. So the first step here under mathematical induction, so we're going to say step 1. So here we need to show that this statement that we have is true for n equal to 1. So here we say we need to show that the statement that we have here is true for n equal to 1. So what this simply means here is we're going to get from the left hand side of what we have here, we're going to get this expression where this n we equate it to the right hand side here. So we're going to have n to the power 3 equal to n squared here, n plus 1 squared divided by 4 here. Then where there's n here, we're going to substitute the 1. So here we're going to have 1 cubed is equal to 1 squared, open brackets, 1 plus 1 to the power 2 divided by 4 like this. So then we evaluate this here. We're going to have 1 this side and 1 open brackets, 2 squared divided by 4 here. So then here we have 1 is equal to, so 2 to the power 2 is 4 multiplied by 1, we're going to have 4 over 4. So we have 4 over 4 this side, which is just 1 equal to 1 like this here. Therefore, the statement that we have is true for n equal to 1. So this is the first step under mathematical induction. Okay, let's go to step 2. So step 2 we call it the inductive hypothesis. Okay, so step 2 is the inductive hypothesis. So under the inductive hypothesis here, we make an assumption where we assume that this statement that we have is true for n equals to k. So here we say we assume that the statement is true for n equal to k. So here, the only thing that we're going to do under the inductive hypothesis is we're going to substitute with k where there's n in the expression that we have above here. So meaning that this becomes 1 cubed plus 2 cubed plus 3 cubed plus. So where there's n here, we're going to substitute with k. So we're going to have k cubed equal to k squared, open brackets, k plus 1 the power to the side divided by 4 here. So this is the only thing that we get to do under the inductive hypothesis step. Now we go to step number 3 where we have to support the inductive hypothesis. We need to show that the statement that we have is true for n equal to k plus 1. So here we're going to say step number 3 here. So step number 3 here, we need to show that the statement is also true for n equal to k plus 1. So what this simply means here is that, for example, if you have numbers like 1, 2, 3, 4 like this, these are natural numbers that are written here. And our n in this case is ending at 4. When we say n plus 1, we're simply adding a new term to what we have here, meaning that we're going to list a 5 like this here. So then, with regard to what we have here, we're going to write up to the k term here. So we have 1 cubed plus 2 cubed plus 3 cubed plus all the way up to k cubed like this here. Then now, since we're saying this has to go up to the k plus 1 term, so we're going to say plus, we're adding a new term now here, k plus 1, so meaning that we're going to have open brackets, k plus 1 cubed like this here. Where there's n here, in this expression that we have here, we substitute with k plus 1 here. Then here, we equate this to open brackets, k plus 1 squared, open brackets here, k plus 1 plus 1 to the power 2 divided by 4 this side here. Alright, so we can go ahead and solve this now. Okay, sorry. Okay. Alright, so you notice that starting from this term here, the first term that we have there, all the way up to the k term here, this gives us the left hand side of the inductive hypothesis here. So meaning that where there are these terms here, we can just substitute with the right hand side of the inductive hypothesis. So here we're going to have k squared, open brackets, k plus 1 squared divided by 4 plus k plus 1 to the power 3 here equal to k plus 1 squared. Then inside here, 1 plus 1 are going to get 2. So we're going to have k plus 2 squared. Everything here we divide by 4 like this here. Okay, so I'll scroll to the next page here. So our goal here is just to show that the left hand side that we have here is equal to the right hand side. So we just need to show that the left hand side is equal to the right hand side, then we show that the statement is true for n equals to k plus 1. So here, let's go to the next page here. So we have k squared, k plus 1 squared divided by 4 plus k plus 1 cubed equal to k plus 1 squared, open brackets, k plus 2 squared divided by 4 here. So we try to evaluate what we have on the left hand side, this side here. These two terms on the left hand side are fractions, so we try to make them a single fraction here. So this is the same as divided by 1 here. So the common denominator that we have this side is 4. So here we have 4 below here. Then 4 into 4 we get 1. 1 multiplied by this here. We're just going to have k squared, k plus 1 squared plus 1 into 4 we get 4. 4 multiplied by that we're going to have 4. Open brackets, k plus 1 to the power 3. This is equal to k plus 1 squared, open brackets, k plus 2 squared divided by 4 like this. Now, if you look at these terms that we have on the left hand side, this side here, you notice to say that we have k plus 1 squared common here. So here we have k plus 1 to the power 3 here, and this side we have k plus 1 to the power 2 here. So meaning that k plus 1 squared is common on the two terms here. So I can just factor it out. So meaning that here we're going to have k plus 1 squared. Then we're left with here. If we factor out k plus 1 squared here, we're going to be left with k squared. Like this here. Plus, then this side, if we factor out k plus 1 squared, we're going to be left by with 4 open brackets, k plus 1 like this. Then we close. Then everything that we have divided by 4 equal to k plus 1 squared, k plus 2 squared divided by 4 here. Then if we expand the brackets that we have inside here, we're going to have k plus 1 squared, open brackets, k squared plus 4k plus 4. We close here, and then we have this below here equal to k plus 1 squared and k plus 2 squared divided by 4 here. Now, this expression that we have in this bigger bracket that we have on the left hand side here is a quadratic equation. So you can just try to factorize that equation that we have there. So we have k squared plus 4k plus 4 like this here. So our product in this case here is 4. Our sum is 4. So two numbers we can multiply to get 4. We add, we get 4 again. We're going to have the factors that we're going to have here are 2 and 2 like this here. So this becomes k squared plus 2k plus 2k plus 4 here. So on the first two terms that you have here, you can factor out k. So we're going to open brackets k squared or k here plus 2 plus, then here you can factor out a 2 there. You remain with k plus 2 like this here. Then you're going to have k plus 2 and k plus 2 here. Now notice to say that it's the same thing that you are multiplying by itself here. So meaning that this is the same as k plus 2 to the power 2 here. So meaning that here, this here is the same as k plus 1 squared. Then here, since we've evaluated with this side here, we're going to have k plus 2 to the power 2 here divided by 4, which is equal to k plus 1 squared, k plus 2 squared divided by 4 like this here. So therefore, we have that the left hand side here is equal to the right hand side. So once we achieve this, we can just say this statement is true for n equal to k plus 1. So if this statement is true for n equals to k plus 1, then you can just say the statement is true